Greetings, detectives. We are about ready to finish up the clues for case 2. This is clue 7, and it's all about graphing systems of inequalities. So let's go ahead and start by writing our learning target. I can solve a system, so write the word system, of inequalities. Now, we've learned several things. We've learned how to graph systems of equations, and we've learned how to graph inequalities. But this is the last thing, graphing a system of inequalities. So let's just do a really quick review. Let's start by just reviewing what a system is. Remember, a system is two or more equations, and now a system of inequalities is two or more inequalities. And we're looking for the places that those two equations or those two inequalities have in common, the place where they overlap. So in a system of equations, we are looking for hopefully a line, two lines, and a point where the two overlap, right? Then with a system of inequalities, we're actually looking for an area where the two interlap. So let me show you what I mean. When we graph inequalities, remember that it's an entire half plane that gets graphed. So that would be one inequality that gets graphed. And then let's go back and let's say we're going to graph this inequality. And it looks something like this. And what we're doing is we're looking for the place where the two inequalities overlap. And that is right here, this section right here, this whole section coming down this way. I just didn't make my blue go all the way down. So the place where the two overlap, okay? The two areas of the half plane where both inequalities have true points. The points are solutions, okay? So that's one thing. The second thing that you need to remember, and this is a common error that students make, is that you have to remember that when you're graphing your half plane, if you have greater than or less than, your half plane boundary is a dashed line. And when you have greater than or equal to or less than or equal to, your half plane is a solid line. So those are important things to remember. Another thing that's important to remember is how to decide which half plane you graph. And you can do it one of two ways. If you have your boundary in slope-intercept form, y is equal to mx plus b. And if this is greater than, then you shade above the line, if it's so above. And if it's less than, you shade below the line. But that only works if you use y equals mx plus b format, okay? The other way to know which side of the boundary you should shade with an inequality is to test a point. And I always test 0, 0 if I can. And if the point is a true statement in the inequality, then we know that that point is part of the solution, and so you shade that side of the half plane. If the 0, 0 or whatever point you use does not make a true statement, then we know that is not a solution, and therefore everything on that side of the half plane is not shaded, it's the other side. Okay, so that's our review. Let's move on to solving systems of inequalities by graphing. Now, this is pretty simple. If you understand how to graph an inequality and you can be neat with your graphing and be able to tell what you're shading, then you'll do just fine on this, okay? If you don't really understand all of the steps in solving a system of inequalities, then you should probably go back and review that. But let's go ahead and do these two problems. This first one says, solve the systems of inequalities by graphing. So we have y is less than 2x plus 2, and y is greater than or equal to negative x minus 3. Now you can see that right away I've already put these in slope-intercept form. I don't have to do any moving around. But if you had an inequality that had the x over here on the left-hand side, you'd want to get it over on the right-hand side. You'd want to go ahead and get your inequality in slope-intercept form. Y equals mx plus b. And the reason we do that is because it's just quick and easy to graph a line that way. Now, you don't have to do it that way. You can always choose to plug 0 in for y and 0 in for x and get the 2 points for your y-intercept and your slope-intercept, or your x-intercept. Plot those 2 points and connect your points. Connect those 2 points to make your line. If you do that, then just make sure that when you are deciding which half plane to graph, that you go ahead and test a point, or you make sure that your line is in slope-intercept form to be able to use the little trick of below or above the line. All right, so let's go ahead and get started. Y is less than 2x plus 2. So to graph this line of y equals 2x plus 2, I'm going to go ahead and graph my y-intercept, which is 2. Let me use a different color. And I'm going to go up 2 over 1, and that's because my slope is 2 over 1. And I'm just going to go down to back 1 because you can see that negative negative still makes a positive, so that I have a nice little line there. And I'm going to look at my line, and I'm going to look at my inequality, and I'm going to decide whether my boundary should be dashed or solid. So it is not equal to, it doesn't have an equal to sign underneath it, so that tells me that it's going to be a dashed line. So I'm going to draw my line first, and then I'm going to erase it to just make a little bit of a, make it look dashed. Oop. Well, let's start that again. Well, let's see if we can try it from here then. All right, it's kind of a sloppy line. Well, not quite what I wanted to do, so let's okay, so sort of a wacky looking line, but I'm going to go ahead and make it dashed. Actually, let me see if I can finish making this line. All right. And the little arrows here. And we're going to go ahead and make it a dashed line. And then I have to decide which side of the half plane should I shade. So I'm looking at my inequality, and my inequality says that it's less than. So less than means I would shade below the line, and I'm just going to double check that by going ahead and testing the point 0, 0 in here. So if I put the point 0, 0 in place of x and y here, I would have 0 is less than 2 times 0 is 0 plus 2. 0 is less than 2. That is a true statement, so that means that the point 0, 0 is included in the solution, and that's below the line. So I'm going to go ahead and just shade very lightly this side of the line. And the reason I'm going to do it lightly is because I'm going to be covering it up. I want to be able to see the section where my two overlap. And if I do this too darkly, I'm going to just have a big mess. So there's my half plane and it's shaded. So now I've graphed one inequality. Now I want to graph my second inequality. So I'm going to use a different color on that one. I'll go ahead and use red. And that one is y is greater than or equal to negative x minus 3. So I'm going to start by double checking and making sure it's in y equals mx plus b format. It is. The only thing I need to remember is that this is a negative 1x. So negative 1 over 1. So my slope is a negative 1. All right, so I've got negative 3 is my y-intercept. 1, 2, 3. And then I'm going to go down 1 over 1. Or up 1, back 1, because a negative 1 slope always has one of my lines being negative, or one of my changes being a negative change. All right, so there's my slope, or my line, my boundary, and this time I'm going to have it be a solid line because it's greater than or equal to, which means that my boundary is actually included. I'm going to see if I can do this without making a huge mess again. I go fast. Nope. All right. So now I've got my very sloppy line, but you get the idea. And this time I'm going to figure out where I'm supposed to shade this one. So according to my inequality, it's greater than or equal to, so it includes the line, and it should be shaded above. But let's just double check by trying our point 0, 0. This point to see if this is included. So 0 is greater than or equal to 0 minus 3. So is 0 greater than or equal to negative 3? Yes, 0 is greater than negative 3. So I'm going to shade now above the line. And what I'm looking for is I'm looking for the place where my two inequalities overlap. And I'm hoping that you see that it's right here where I'm shading. So it's not this part over here, because that only is red, but it's the part where the red and the blue overlap. See that? So I'm actually going to change that color to sort of a purple color so that we can see it even more obviously. Make it even darker. And this is the section of the two inequalities where it is a true statement for both. Any point that I pick inside this purple shaded area will be a true statement in both inequalities. I can't go below the line. I can include this line right here, the red part of this line, but I couldn't include the blue part because that is not included in the inequalities. It would be true for the red, but not for the blue. So that is the section of my inequalities. That's my system of inequalities. The two inequalities have been graphed, and I've looked where the two overlap. Okay? Let's try the next one. Actually, I think I want you to go ahead and graph this first inequality. So take a minute and graph this first inequality. You're going to have to graph the y-intercept, and then you're going to have to graph the slope. Okay, so go ahead and try that. So you should have done one at the y-intercept, and then done a -3, 1, 2, 3 over 1, 1, 2, 3 over 1. This is a solid line, so actually I'm going to do this one up here too. 1, 2, 3 over 1. So your line should have looked something like this. Something like that. And seem to be having trouble with lines today. Put your arrows on either side. And then you needed to decide which side to graph on. And you could have tested the point 0, 0, or you could have looked to see that this is greater than or equal to, because this is in y equals mx plus b format. We can use that. It's greater than, so therefore you should have shaded above the line. Ignore that part that I just went past the line. That doesn't belong there. So now that you've graphed one inequality, why don't you go ahead and try to graph the other inequality. Do the same thing. Graph your y-intercept and then your slope. This time, your line, your boundary, should have started at, oops, not there, should have started at 1, 2. Get rid of that one. And let me get rid of these two. Okay. Your boundary should have started at the 2, which is our y-intercept, and our graph was -3, same as our other one. So that means a -3, 1. I'm going to make my line just a little bit smaller. So we're going to go from this point, we're going to go 1, 2, 3 over 1, 1, 2, 3 over 1. This is going to be very tricky. Do you see how close these two lines are? And with my terrible graphing at the moment, Okay, so there's my line, trying very hard to be as neat as possible. Okay, so these two lines have the exact same slope, which means that they are actually parallel lines. So that means the boundary of my blue is parallel to the boundary of my red. But the question is, where, if I need to, so they look like they're almost the same line, but they're not. They're just a little bit apart from each other, and they should be parallel. It's just my drawing is terrible. So let's go ahead and finish graphing the inequality. This time, it's also greater than or equal to, or it's got the equal to, so it's a solid line. And we are going to now say that y is less than, so that means everything underneath the line going this way. And if you can tell, there is a very, very slim section where these two inequalities overlap. And it's actually between, it's that small slice in between the two boundaries. So the red's going this way, it's underneath the line. The blue is above the blue line, and the place where they intersect is right in here, that little section right in there. So not a lot of common area, just that little slice, which I'm doing a terrible job shading, but you get the idea, okay? So that's how you graph systems of inequalities. Now, there are two things that you should always remember. One is, don't forget that parallel lines won't ever intersect. So when you're graphing a system of equations and you have parallel lines, you'll never have a solution. But as you can see in this situation, where one of the inequalities is greater than and the other inequality is less than, there will probably be an area in between the two inequalities where there is an intersection. So even though the parallel lines won't ever intersect, there may be space in between those two lines that will be a common solution. And the other thing is, you always have to pay attention to the inequality and shade the appropriate half plane. Really, really, really pay attention. If you need to flip signs, flip signs. If you need, just make sure that you're very careful and that you're doing it step by step. And that is how you graph systems of inequalities. So you graph each inequality, making sure to shade the half plane of each one. You find where the two graphs overlap and mark that area. And then, and you just want to make it very clear. So when you're doing tests or quizzes, you're looking for the exact place where the two overlap. Okay, so in this one up here, it was this whole section here going on and on forever. In the second one, it was the little slice in between the two inequalities going on and on forever. Now it's time for you to write some key ideas, and I will see you in class.